All right. So, yes, today we're talking about Chapter 9, Program Controls. And basically, what we're doing is going over the, the basics of program controls, what program controls are. Um, what you can do with program controls is manipulate the program. So, up to this point, we've written code. We've done all kinds of things to make outputs come on. We did timers, we did counters. We've done things with the code. The timers and counters, we're starting to automate things, but now we're going to go to the next level. So now we're getting to the advanced portion. So this is actually going to be the portion that we're actually going to work with. It's going to be um, how to manipulate things within the program. So let's kind of explain how that is. So the first thing we're going to do is called a jump, jump to label. So we're actually going to jump to a location, and if you look on to page 185, this is all listed out. So the basically what we're doing is we're going to talk about the jump. So the jump is you can jump forward or backwards. You can jump within a program. So let me kind of emphasize that, and I'll explain this a little bit more as we get to our actual program itself. So we can jump to and from something. So as soon as for the jump instruction, as soon as that the rung of logic is true, it's going to jump to a location, meaning that we can jump over code. You can say, okay, I'm going to go through line or rung 2, 3, 4, and I'm going to jump over and go to rung 7. Right, I can just completely jump over that logic for whatever reason you want to do that. The next one is the label we're going to talk about. So the label is you always jump to label. So they have to be addressed exactly the same. And when you jump, you're going to jump from a jump instruction to a label. So the label's like the receiver. The jump is where you would leave from. Then we got JSR, jump to subroutine. This is basically going to be the fact that you can jump to a smaller sub program. We'll talk about that as well. A return, how to return back from that. We're going to talk about the subroutine itself, and temporary ends and master control resets and suspends. So these are all things that are going to be in this chapter that we're going to kind of cover. But again, they are instructions on how to control the program itself, how to actually make it, manipulate it, and do something with it. So, okay. So we talk about the MCR first. So what an MCR is, and I think what I'll do, let me go ahead and pull up my program so we can do this simultaneously, and we'll build it. Now, I kind of explain as we go. Now, the problem I've been having with my setup, let me see if I can pull this up real quick, is that I'll switch you over here so you can see it. Let me get myself ready. The problem I'm having is that I still have the demo version as well, and you can't save on the demo. So let me switch over to there. Okay, now you can see the screen. So I'm running a demo version of the program, and if you don't have the program yet, I am going to put the download link inside of Canvas, but I haven't done it quite yet. But if you want to do it now, which I suggest, if you go to plclogix with an x.com, plclogix.com, on the main page there is a section. Let me just click on this here. There's a section here that allows you to download the 500 and the 5000. We're going to be doing the 500 for the next few chapters. Will be 500. We will skip over to 5000. If you already have that $20 one from last semester, you can use it as well. This one here is just happens to be the one we're going to be using later. As soon as they release the code or the access code to actually release it, then I'll distribute those to you all, and we can move forward into our chapter, our lessons. But at the time being, we're all on a 15-day trial into that point. So I just want to keep moving. All right, first thing I do, we're going to go ahead and click on File. We're going to say New, and we'll do this later, so you can kind of see what's going to happen. And a screen pops up. It looks just like this, and we got to give it a name. So let's call this a program control. Doesn't matter what you call it. So basically, that is just the name of the processor. It just so happens it also names the program that as well. So when you do save it, it will do it. But again, we're in a demo, so it won't let me save it anyways. But okay. So if when you go to the top menu here, you're going to see all the way to one side. You're going to see a tab called Program Controls, and these are all we're talking about today. These are what's going to be considered what we're doing. So what a master control reset does is very similar to a master control relay. So let me kind of explain this real quick. A master control relay is a contactor or relay that allows you to disconnect a circuit. So if for some reason something bad happens, let's say that we have someone's getting their hand caught into a machine, or something's catching fire, or something's happening to a machine, you can hit a e-stop or some kind of a stop system, and it will disable or pull apart the circuit with an electromagnetic switch, a contactor. Once that disconnects, we lose power to the entire system, and then, or at least that part of it, and then it goes away. Like you have no power, you physically just dies, right? This is the digital version of that. So they can't call it master control relay, but they call it master control reset. The rules behind it is you have to have a start and a finish, and those are called fences. Anything in the middle is called the zone. So you got MCR zone, which is the section in the middle, and then MCR fence is the top and bottom. So if I was to show you this here, let's say that, let me just go ahead and build a small little program. And again, we'll be doing this a little bit later, so just kind of watch along. I'm going to add a few rungs. There we go. And let's go ahead and add just a couple conditions for whatever reason. We're going to throw some things in here. I'm going to bring some down. And I'm going to just use examine if closes right now, just to keep everything nice and simple. Let's put it on this one. Okay. So, first I'm going to just give these things some names. So these are inputs. So I'm going to say that this is input I, :1/0. I'm just going to give it a name. Okay, we got I, :1/1. Again, we're addressing just like we would last semester. I, because it's an input, 1/2. We'll just fill these out real quick, and then we'll explain what the MCR does. Okay, so we got all these in, and we are now, these are just basic inputs. All right, so let me kind of compress this a little bit because I'm going to bring in the other stuff here in a second. Let me get this out of here. Oh, one thing I wanted to show you before that's the reason I had this up here. The school is offering open spaces for labs or whatever, and for some reason, if you're having issues with your internet, you can bring your own device to Moyer 203 or 209, or go to the computer lab at 211 if you actually want to use their computers. But you can't load your this software on their computers, so you got to bring your own if you're going to do that. But I just wanted to mention that. That's why it's up there. All right, go away. All right, now kind of stretch this out so I can see it, and then we're going to add our MCRs. So I'll go back to my program controls. Well, first, before I do that, I'm sorry. I got to add my outputs. These things need something to turn on. And one more. I'm leaving 2 blank, and there's a reason for that. Okay, I'll put this output 2, 0. So I have output 0, 1, and 2, and then, of course, input 1 through 5. You saw me do that. So this is a regular program. This would run normally, besides the fact that it won't do anything with the outputs missing. It is a regular program we've learned up to this point. So what we need to do now is add our new features. So we're going to program control. We're going to take an MCR, and I'm going to drop it on this rung, and then I'm going to do an MCR and drop it on this rung. Now this one here is unconditional, and with a MCR you don't need any other conditions. A normal, typically you wouldn't do that because whatever is on there is going to be on all the time. With an MCR fence, this one here is basically the end, and it really doesn't matter. You can have that empty if you want. This one here, this input 1, 2, is going to be for the purposes of turning the MCR fence on and off. All right, so at this point here, let's go ahead and test it. I'm going to go to IO Worlds, open the IO rack, and it's going to bring up this here. We don't need all of this. I'm just going to minimize this down to what we need. All right, and then of course if you start clicking on it, nothing's going to happen because we're not online. So what we have to do is normally you would download it to the processor. Obviously we don't have one, so there's no option for download. But we're going to say go online, and you're going to see the bar turn green. All right, so I'm going to start clicking on it. You can see that there's 0. You see it turn green, so that's now true because I'm sending power to it. It wants power. It has power. It's now true. And I'll do the same thing for 1 and so on, right? I did that to me yesterday too. If this thing does this whole thing and then it locks up, then I can't. I got to start over. All right, before it kicks me out here, let me show you, because I got to redo the whole thing again. Basically what happens is there's an MCR fence at the beginning, at the end, and as long as the MCR fence, this here is not true, right? Because right now it's not. Anything in the middle here, all the outputs that are within this fence would be false. They don't allow you to, it won't come on. But as soon as this rung here became true, it would allow everything within the fence to become true. All right, so I'm going to click on OK to satisfy the thing, but it's going to drop the thing out. Then I got to start over. Just give me 1 second. It did this to me yesterday a couple times while I was recording the lecture for Monday's class. And
Wonderful, huh?
What's that? There we go. Yeah, it was B&H Photo. Can I help you? Oh,
Sorry about that.
oh, it's okay. All good.
When you start turning 65, Medicare and everybody and their mama wants to talk to you.
All right, let's do this again. So typically I would say open, and I'd open up something. I'm just going to do a so on the other screen you can't see. I just typed in test just to have something to start. All right, let me do a quick one again, and then yeah, I think I made the video 5 or 6 times because it kept on doing it, and but right when I was getting ready to demonstrate something, went bump. I was like, oh. So I think one of them I just left it in. I said, you know what, forget it. But yeah, I did a video. So if you ever want to go back and watch it again, I did it in like a little 4 or 5 minute segments, just to keep things moving.
So are we going to have that issue as well? Is that something that we need to prepare to do?
I don't know. I hope not. I am. I'm hoping that that this situation. Well, I think the fact that we're running it as a demo is not helping it much, because you can go here, you can say save, you can do all that stuff. For some reason it's just not letting me save. It goes through the motions, but it doesn't actually do anything. So if it does it again, I'll go back to the old software and we'll do it through the old software because it has the same thing in it. The only thing that it just doesn't have the more advanced your stuff here, but we'll go back and forth if that's the case. Okay, let me try this one more time. Sorry guys. I'm going to make a shorter version so I can kind of explain what's going on. And I don't think it's because my processor, because right now I am doing like 8 things at once with it, but I don't think because even when I was offline by myself, it did it. So I'm not sure what the I believe and hope it's just a software issue. I mean a demo issue. Something's not jiving just right. All right, so I'm gonna grab this, put it here. You guys are welcome to build along with me as I go, because you can kind of
Yeah,
see.
yeah, I was going to say I'm installing the demo right now, so we'll see if that problem is just isolated to you or not.
Okay, I hope it is. I hope it's just my issue. This thing will let you put a 0 instead of an O and a 1 instead of an I, but it will not run it. So when you go ready to, it's not going to throw an error up like a normal PLC would, because normally it would say, nope, this isn't a valid word. Um, like if I was to put a 0 here instead of an O, it would accept it, but it would not run it in the simulator. It just wouldn't turn on. It wouldn't know who to talk to. So at least that part works nicely.
So is there a minimum or maximum number of lines we can have between the start and the finish of the master control relay?
No, nope, not nope. You can do as many or little as you want. So I put one. Last time I had two, but it really doesn't matter. Yeah, it's whatever you need to shut off. So whatever's in between those fences, when that MCR is false, anything in the middle is completely dead. Um, Now there's some rules to that as well, like everything else. If you have a TOF timer, the TOF timer will start as soon as the fence goes off. So if your fence is on, because a TOF, it is true. It starts counting when the rung it's on goes from a true state to a false state. So if that happens in this, your timer is going to start like it normally would. A TON, like an on timer, is going to not do anything. A retentive is going to stay where it is. If you have a latch or unlatch, specifically a latch, anything that's retentive, it's going to keep it and maintain it. So a counter is going to stay the same. Your retentive timer is going to stay the same. They're just going to lock where they are. They're kind of like freezing time. And um, your latch, if it's something already latched on, it'll stay on. If it's latched off, and I'll do it on here to show you. But yeah, that's a good point. Anything in those fences will go away in the lock when it goes off. All right, so let's do this one more time. Let me go to my IO rack. And the only time this thing does it is when I've noticed is when I'm running the simulator. So I'm not sure if it's doing too much at once for me or what. But let's try this. Okay, I'm going to go online. All right, so the bottom one is unconditional. You see that this here is a fence. Oop, Chris Miller's trying to get in. There we go. Sorry, I had one more student trying to get in here. Where's that screen at? I lost my screen now. All right, I'll fix it in a second. So yes, basically what's going to happen is you're going to have your MCR fence here. This one here is going to be positive or true, and because there's no conditions, it's on. But the zone is not activated because the beginning one is not. But if I go to input 1, 2, I go here, I click on it. Now this zone is activated. That kind of makes sense. So when the start is activated, you're going to see the whole thing activate. And you could put input 1, 2. You could put that down here if you wanted. It really doesn't make a difference. So let me demonstrate what's going on here. So let's say that I had input 1, 3. So this condition is now true, and in the real normal world, you would see that this would be true. But because my zone is turned off, this is not happening. But let's do 0 and 1. There's 0 and there's 1, and it came true. Dang it. And it came true, right? So when those two happened, it came true. But when the MCR is not active, it didn't. And it messed up on me again. So, and I'll move on to the next after this one here. But basically, if it's within this fence, this line has to be true in order for whatever is between these two to be active. If I was to be able to turn on 1, 2, you would see the MCR come on, and then the output would instantly come on. If this is still true and the zone goes off, then you'll see the exact opposite.
So Joe, the finish line is always for your master is always going to be on, irrespective of whether the zone is activated or not.
Yes, if it's unconditional. You could have a condition on there where, so the reason they typically use these is when you want to turn off a section of logic that is, we let Drake in, turn off a section of logic that is, let's say, a fault. Let's say something happens and you have a set of pumps running or motors or something that is dangerous, something that is going to hurt somebody or mess a system up, right? You put those things within this zone and you say, okay, if this fault happens, I want you to go ahead and activate or deactivate this MCR master control relay or reset instruction, and you're going to go ahead and take all those out. Now, I keep saying master control relay because that is the device, the actual real device, and we'll talk about that later. The MCR in this case is master control reset, and I think I messed up in the video as well, but you'll get the idea. So yes, that is the basic outline of it. Is if anything you want to turn off, you put in this zone, and it cuts off all that logic at once. Even though the inputs and everything else, the conditions are right, everything's fine, it's going to drop that part out, so it's not going to work. All right, let me move on to the next one, unless you guys have any questions, and I will let me open this back up again. And once it opens, I'll drag it over so you can see it. It's no fun if I'm just doing it by myself. All right, let me get myself out of here. All right, so what we're doing now, we're going to go to the next part, which is, first of all, did that make sense? Did anybody have any questions about that part before I move on, before I lose anybody? Because this is the semester that just, you got to ask me while we're doing it, because we're going to keep moving very quickly, but I do want to make sure that everybody is, I do want to make sure that you're actually understanding it, because we're talking about complex things here. So before, I wanted you to get it, but I just wanted you to kind of get the information kind of spoon-fed to you to get used to it. The examine if open, examine if closed, the outputs, the latches, the timers. That would just kind of, I did it very small chunks. This one here, we're doing a lot of information, but I just need to make sure that it's secure in your head before we move on to something that's more advanced. So please tell me if it's not. Okay. The next thing we're talking about is a jump instruction. So we talked about this previously when I did my intro. Basically, this is a way to jump around a program. So I'm going to do the same thing. I'm going to open up. I hope it's done. Do it the whole time. I know I said I opened the other one, and I will the next time. If this does it again, I will definitely go over. Okay. So a jump instruction allows you to jump within or around a program. So again, let's put on, I'm going to just do a couple here. I'm not going to do a big one because this gets old when I have to redo it over time. So let's say I have 4 rungs, and let me put another guy here. All right, and let's put some outputs on these things. Actually, let's move that there. And let's do one more. Okay. Now this one doesn't have the ability to drag in addresses like your other software did. The real one will, this one does not, which is a downside, but this one is much more advanced than the previous one as far as what it can do. So that's why I was pushing so hard to go to this direction. Okay. I'm just simply addressing these again. So if you want to follow along, please do. Has anybody else crashed yet? Everybody else good?
Well, I'm trying to follow you without getting distracted. So,
Oh, no worries, no worries. You're Phil. You said yours hasn't yet.
oh, I haven't. I've just got the rungs up. I haven't done anything else.
Okay.
I haven't noticed a problem yet.
Okay. Good. I hope it's just mine. Hope it's just my version or something. Um, but we'll try it. For those of you that came in late, I'm not sure if you heard that we're just using this software. You can download it from plclogics.com with an X, but you also get a link in the coming up here in the next couple hours when this class is over. I'm gonna start working on or start finishing up our this week's Canvas module. All right. There we go. All right, so this is, again, it's a basic layout. And then I'm going to add the jump. So I'm going to go to my compute once again. Oh, program control. Not compute, sorry. Program control. I'm going to do a jump. So I'm going to put a jump on this location. And I got to jump somewhere. So I'm going to say I got to jump to a label. So I'm going to jump here. So I'm going to call this one 1. I'm going to give it a name because if you look at the address, it's different. So if I can zoom in on this thing and show you more. Oh, well. If you notice, it says Q2 and then :1. So on this software, you don't have to type in all the Q2, and I'm thinking on the other one you don't have to either. I think you just put in 1 or 2. The Q2 basically is its own little address for jumps only. So jumps are the only thing that would have anything with Q. So if you look at you look at your stuff here, you're going to see that it has a Q2 : and then a 1 or Q22 or whatever it is, right? The reason it's 2 is because we're in routine 2. If you want to jump to a subroutine, we'll talk about that later, you can say 3 or 4 or 5, whatever. It jumps to wherever you tell it, but this one lives on this guy, right? So Q21 was going to jump to another Q21 label, which you'll see at the bottom there on rung 3. So this will jump to here. So let's say that, let's try this again. I turn my IO rack on. All right. I'm going to, all right, let's say that, well, let's got to run. I'm going to go online. Okay. Now, this one here, it says it's active. I'm jumping to, but that's not, as you see, it's not ready to jump. But if I do the 0, you're going to see that, what's going on here? You'll basically will be able to see that this one's true, and then the output here is going to be this rung is now true. And then, I wonder if it's because 0 seems active on me. I don't know why. I can stop using 0. But this one here is, if these two were true, then the jump routine would become active, and it's going to jump over rung 2. So it jumps from rung 1 and jumps to rung 3. So, and this doesn't have to be one rung, this could be 50 rungs. It just jumps to somewhere else in the program. You can even jump backwards if you wanted. So let's say that you are on rung 50 and you want to jump up to rung 3. You just got to be very careful not to put yourself in a loop, because if you're in a loop, it will slow down the scan process, and then something called a watchdog timer, which is like the master timer for the whole program. It will eventually kick in and it'll say, something's wrong, I'm going to shut it off, and you have a fault. You're at fault. So if you have it just constantly going in a loop, it's going to mess up. But you can jump backwards and scan something once again before the end of the scan. So basically, let's say that we are reading rungs 1 through 20. Just read them like normal. We get to 20, it says it jumped to 50. It jumps to 50, and now you have completely skipped over anything between 21 and 49. So all those are completely out of the, they're just not being scanned. They're not even looked at, right? It just skips right over them. And then, for whatever condition, let's say that you don't need to look at that code. Let's say you don't want to access or turn something on. You can jump right over that, and that's fine. If for some reason you needed to double back, you could tell it to jump back to, let's say, rung 19, and then you can have it scan again. So if the condition is now changed where it doesn't skip over that, you can have it run and scan over it. It's not necessary, but you could do that because it'll catch on the next rung. If that was all of a sudden whatever rung told to jump is now false, it's going to it'll scan everything the next time. So it'll scan 20, 21, 22, 23 all the way down. So okay. All right, so that is the jump. And again, you can jump back and forth. You can jump anywhere you want. Let me click on this so we can do that. And I'm going to open the other one up now. But for some reason, I don't know why it doesn't like that, or it's something that I'm doing on my end. But I just can't keep rebuilding this thing all class. Because I want to send you guys to do your labs. So this is the $20 one we had last semester. And it doesn't have all the bells and whistles, but it didn't crash, so that was good. And it's probably mine. It's probably something I did. All right, open this up. Go to my simulators, do my IO simulator. Okay. And then I'm going to add some rungs. Now this one here, when I started, it didn't ask for processor, didn't ask for any of those things. It just doesn't care because again, it's a basic scan program. So, all right, so let's go ahead and build another just generic program that I can throw some things on here and hopefully show you where how things work. Okay. All right. Let's do this one here. And this one here. Okay. So let me give this guy a name. And probably starting next week, I'll be actually on campus, streaming from there. So probably see things work a little bit different. You'll see different, and then probably, of course, I gotta stream a little bit differently because I'm not gonna have all this stuff at school like I do here. So it won't be as many things going on here as it is here. I'm gonna address those the same. Those examine if opens, and I'll show you why. I just want to try something different. All right, there's 3. Again, demonstrating that you can have multiple addresses all named the same, and you don't even have to. You don't have to have one individual address for every single input. You can say, okay. When this happens, all 3 of these are going to react to the same switch. All right, and then the output, I'm going to cheat a little bit here, because this one does let me do it. Oops. Yeah, if you have this software here, it's still great. I highly recommend this one as well. All right, and then I'm going to go to my program control. I'm going to throw a jump in here, just like before. I'm going to throw a label. Okay, and then I'm going to put in a MCR, and then of course you need a second one to close that off. One other thing, you don't want to jump within an MCR fence. Now I'm gonna let this go, but that's another thing I forgot to tell you. Don't jump to the middle of the MCR fence, because if an MCR fence is disabled, when it jumps there, everything within there is gonna be off. It's not gonna scan it, and then you move for no reason. So you cannot jump within an MCR fence. Let me add one more rung so I can do this properly. There we go. And let's do one there and one here. So what, I stop at 4. All right, let's grab 5. And that one there is 2. There we go. All right, so when everything starts up here, we should be able to see that we have the, when this comes true, we're going to activate our MCR fence. That means that rungs 1, 2, 3, and 4 will all be active. When I disable that, all these will go away. So I'm going to do the same thing. Now this one here, it does simulate a download, so you got to download it. All right, and then I'm going to go online. All right, once we're online, we got to put it in run. Now, if I was to, let's say, push, I'm going to sit there and push 1, it's going to turn on the MCR. You see it says active. That's not what really happens, but it should turn green. But the MCR fence, that means anything within here is now working. So if I click on 3, you're going to see that when I click on that, you can see that rung 2 come off and on. All right, let me flick it over to a maintained right there. Let me do one more so I can do a couple things at once here. There we go. So if I was to click again, there's 2. Let me take 2 and open that up. Oh, I need it maintained. There we go. That is going to allow us to do something within here, right? That means all these are now active. They can come off and on, and they should work. Now, if I go to MCR4, all right, so that's gonna allow that to happen. Now, if I go up here to MCR1 or 0, I'm sorry, and I turn that off, all right, that's going to drop that out, and those outputs will drop out with it. So they should have no thing. But if you see what happened, watch, I'm going to do it again. All right, do you see what's going on with these outputs? Why are they not coming on? See, it's true. My MCR is active. Why do you think it's jumping?
You disable it in that whole zone.
No, it is enabled because this line is true.
Right, but when you cut it, when you make it not true.
Oh wait, you know I didn't do. No, but I'm actually jumping over. I'm completely jumping over all that stuff there, so it's not even scanning it. That's why it's not turning on. I just noticed I didn't add the other MCR fence.
Yeah, I was going to say it's inside that block, right? So it's not going to chain it off.
Yeah, it's not even going to. Yes, you're exactly right. All right, so I'm going to download once again. Let me turn back online. Okay. So again, let me turn on 1.3 here. Oh, I got to run. There we go. So you see that we're active. And if I was to disable this one here, you kind of see that the ones on the right-hand side, I'm trying to hold this button at the same time, all these here, you can see that these are now deactivated, right? They've gone away. If I release it, I'm simply pushing and releasing 0 on the button here. You can see that these all are on, and then once it's not active anymore, it goes away you'll see it drop out. Okay, but something that is happening is that my rung 1 is jumping over all these logics. So as you see, this is active, and these are true. So normally you'd have a true state. But for that reason, it's not doing it. So let me turn this off. Let me switch that. Okay. Now the jump has gone away, and see what happened? These all came on. So let me do it one more time. I'm going to hold it down. Okay. So now if I was to go, let me turn 1, 2 off. All right. So we have a false statement here. And let me go to 1. Oh, 1, this one. All right. So basically what I'm trying to show you is that if If for some reason this guy here is activated, right? If he drops out, then these guys here are going to be skipped over. So regardless of the what is going on in those two lines, it's going to completely skip over it. So once that jump is activated, it's actually jumping over that. It's not even scanning it to do its thing. So just kind of keep that in mind. So, okay. I need to switch my things here so I get a little more control of what they do. All right, so I need the top one as a maintained close. And that's better. Okay. I'll put these all as maintained so I can put them in whatever position I want and they stay there. And I'm simply just right clicking. That's how I'm getting those to do that. All right, so again, I'll hit the MCR fence on. MCR fence is active. All right. Let me do some logic here. So this is input 1, 3. I can close that. Now that our output came on, you can see our light bulb here on the outputs, right? That all came true. So this rung is true and that rung is true. I mean, sorry, that condition is true and that condition, so that made this rung true. Now I'm going to activate the jump. So I go here to 1. All right. Now, one difference, and this is a very important difference, one difference between the MCR and the jump. When the MCR is activated, everything runs normally. When the MCR deactivates, it deactivates everything in that zone. So if it's non-retentive, which basically means a general output, right? All these here are non-retentive. It completely turns them off. The only ones that would stay on if it was a latch would hang on. So just kind of keep that in mind. So it completely goes through and puts a 0 on everything and tells everybody to shut off, all outputs. The jump leaves it in its last state. So if it was on and it jumps over it and the conditions change somehow, that output stays on, regardless of how the conditions look. So that's something you could be careful with as well, because let's say you're running a motor and the motor has some condition that is for like over temperature, right? If it reaches over temperature, it shuts off, or it reaches the end of its stroke or end of its movement, right? It is completely, when it gets to the end of its stroke, it sits there and says, stop motor, because I don't want to keep driving into something. If that's one of the conditions and you jump over that section, the motor is going to stay on regardless. If you hit that limit switch saying it's reached its into travel, that motor is going to keep on trucking because you completely skipped over it and it never scanned it to say is the switch on or switch off. Because remember, it has those 4 steps. You scan your inputs first, you read your logic, it updates the outputs, and then it does all its housekeeping stuff, its networking stuff. So when you scanned it, that's your first scan, and then when you do the logic, and then it says, okay, I'm going to skip over these sets of rungs, and then when I update, nothing's changed because it told me to skip over. It didn't care, and then it's going to go ahead and leave it on, and then the next time around, if the jump is not there, it will scan it and turn it back off. But just be very careful. So a jump will leave it whatever state it was in, whereas a MCR will completely turn everything off. So that's the big difference on those two.
So is a question, and maybe somebody else is saying it, maybe they're not. The MCR.
Yep.
By you putting a jump in the middle of that, is that not creating a subroutine?
No. That is so.
Because maybe I missed something along the line here, but I thought for sure when you go to the master control relay, everything in that zone becomes just operative within the master control relay. So your normal program is going to work outside of that particular zone.
Correct. Yep.
Is that correct?
That is correct. So the MCR fence only affects the stuff within it. And like I said earlier, the rule of thumb, you never jump to within a MCR fence. As a demonstration, I'm putting the jump within it, but it's really not advised because you're not going to, that jump is basically, once it goes off, you lose the function of that jump if it's inside there. So right here, when the MCR goes off, that jump is dead as well. So you never jump into a MCR, and you try not to put it in the side. This would work because it would never jump to or from anything because of it's in the fence. But yes, an MCR does not affect anything outside of that fence. Does that kind of explain what you're saying?
Yes.
Okay. All right. So the next thing we're going to discuss is going to be subroutines. So, oh, I guess I can talk to you real quick, and then I'll explain what subroutines are. So a subroutine is a way to organize your main program. So your main program is on program 2. That's your main. That is the main program. Anything besides that is a subroutine. So files 3 through 255 are subroutines. So you can have, a whole bunch of subroutines, and what they're designed to do is they're designed to do a specific task. So let's say you had one that was just meant for heating something, or one that was meant for a cooling system, or one that was meant for a sump pump or some kind of a device that would do something in a situation. So what happens is when a condition is met, you say, okay, I'm going to you could write the code linearly, right? You could put all this information into one large in the main program. You could say, okay, from top to bottom, I'm just going to scan every single one of them, whatever. But 80% of the time, you're probably not going to be using that function. So let's say we're heating something up. We've got a vessel of water, and the vessel of water, it's a big tank, and our conditions are that it's full, it's got a certain amount of water, and that it's at a certain temperature. When the temperature is below the set point, it says, I need more heat. So at that point, you could jump to a subroutine, and the subroutine, it does nothing but light the burners and get everything set up the way it's supposed to be, just so you can get that heated back up. Once it's done with the subroutine, once it reaches and I'll show you here, once it gets to the very end, it jumps back to the main routine, and it comes back in one rung below where you left. So if you left on rung 50, it'll come back on 51. So just kind of keep that in mind too. It doesn't skip over things in the main program. It leaves, it stops scanning the main program, it scans the subroutine, and then it comes back into it. So that's one of the beauties, because you're only doing the heating stuff when you're below temperature. So if your tank is full, so let's say you have two conditions. One is tank full, one is you're below temperature. When that happens, it jumps to subroutine, it jumps over, it does whatever it needs to do to heat the system up, and then when it's done, when the temperature is reached, you go over and you make sure everything's shut off. Turn off your gas, turn off all your stuff. You get everything back to its normal state to turn the fire off so you don't keep heating. And then you don't scan that no more. You don't jump to that subroutine because there's no reason for it. Also, a couple things. You can nest, which means you can put a subroutine. You can jump to a subroutine from a subroutine. Just be careful. You can jump so far out that you can leave 3 and go to 4, and 4 to go to 5, and so on. But by nature, when you finish scanning 5, you have to finish 4 where you left off, and then finish scanning 4, and then go back to 3 and finish scanning 3, and so on, right? So it might take too long to go out and all the way back if you keep nesting. You can nest 2 or 3 times, that's fine. Just be very careful. And the cool part about nesting is that you can make you can make individual programs that are only for certain things. So if you had like a braking system that slowed something down, when it was overspeed, you say go to subroutine. It does all the braking systems to get everything in order for braking. It slows something down, and then when its brake is achieved, it sits there and it'll go back and say, okay, now you check air pressure, whatever it needs to do, and then it goes back to the original. So subroutines are just a way to cleanly break up your program into something that you just don't use all the time. The main program is typically going to be your safety systems. It's going to be your motors. That's another thing. You can, but try not to put any outputs in a subroutine. The reason being is like that scenario earlier. When my temperature was reached and I went to start the burner, if my output was in the subroutine itself, I would turn the burner on, and then when the temperature is reached, this rung is going to go false, and I'm not going to scan that no more. So my last instruction to the burner was turn on. But I never went back and told it to turn off. Now you could write code and say scan one more time and do that one last thing. If this one's false, do a one shot and completely scan this one more time to make sure everything's cleaned up. You could do that. But basically, the best way to do it is to use internal bits, the B3s, your internal data bits, and trigger something in the main. And then the main would then have it. So the main would typically be all your outputs, all your safety systems, all that stuff would be in the main. So I'll leave it there. So you can jump to subroutine to JSR. You can do return. So let's say that for some reason you didn't want to scan to the end. Now, if you see on the one behind me here, this one here is the last rung says end. That is a built-in return. So as soon as it gets to the last one, let's say this is ladder 3, we get to the very last one, it will return back to the main program. It goes back. But I could make a conditional return somewhere and say, okay, I want you to return on rung 3 because I don't want to read rung 4, 5, and 6. I want to leave early. And this doesn't make much sense with a short one, but if you had a super long one, maybe whatever that subroutine was meant to do it was already accomplished. So you don't need to keep on doing whatever down the rung is. So you can say return, it will return back to its main thing. So the subroutines on this software, they're simply on the bottom, and you would click them, and they would bring in. If I was to go to my other one, this is the main screen you would see. So this is going to be your data files, right? So we close this up here. Go to Program Files. So here is ladder 2, which is the main, and then here's it should say ladder 3, but they have it as subroutine. Subroutine 3, which looks exactly like a fresh, clean subroutine, which is exactly what it is. But the program does not know how to get here. That's the thing. So let's go in here and let me put some things. Let's go ahead and put some logic. And let's say that I don't know. I'll put a couple rungs in here and a couple internal bits. All right. So let's say I have that, and then I'm going to put in something here. So each one of these. All right. And then I can go ahead and call this something. Let me see what I haven't used yet. So I'll go to my inputs. And then I can go to, so you can see that the ones with the ones already have, they're already taken up. So I can grab the ones that are not being used. So let's go further down. Let's do a 5. All right, 5, 6, 7, and 8. I'll just put them in order because make it nice and easy. All right, and I'll do the same thing on the outputs. Now you can type these in like I did before. I'm just doing this to speed things up. On 2, and I thought we used outputs already on the 2. Yes, we use outputs. I already have 5 as well. Okay, so I'll start at 6. So 1 through 2. So I need to make sure mine starts at 3. Oh, that's right, but we're not putting outputs here. We're putting binary. So I can go down to the B3s and do the same thing. So I'm going to grab B30, B31, and don't forget these are internal, so these never leave the processor. So these are basically just internal conditions. We got to remember 0, 1, 2, and 3 on their side, or 0, 1, and 2. Excuse me. And I got to make this someone else because he's already taken. Okay, let's make him 9. All right, so that's subroutine 3. Now I could, let's say I put a return. Went too far. Program controls, and I want to do a return. So I could sit there and say, I want to return and Let me leave him. I'll do him later. Let's do our first one first. I'll show you how that works, and then we'll go back. All right, so 0, 1, and 2. So let's go back to the main. And then here, let's say that I wanted to add these in. So I'll go back and add a couple more examine if closes. All right, so I got 0, 1, and 2. All right. So our outputs, like I said earlier, outputs will be living on ladder 2, and our the conditions are on ladder 3. So ladder 3, here's the conditions. Like this could be temperature or level or whatever our program is, right? I'm going to have conditions and some kind of logic here. That is going to turn on bits, and then the bits are turning on things within here. But we have to be able to leave and go down to the subroutine. So let me go here. Let me say that I want to. Let me put it right here. I'm going to add a rung, and I'm going to make it conditional. I'm trying to add all these things on one program so you kind of see them all, how they all work together. That's the kind of the purpose of this whole thing. All right, so I'm going to put condition here. I'm going to grab one that is not being used currently. Let's use 10. So when input 10 is made, I'm going to jump to subroutine. Go to program files. So JSR. And put it right there. And then I'm going to jump to subroutine 3. So when input 0 is true, the MCR fence will be set. When input 10 is pushed, it's going to jump to subroutine 3. 3 is going to be here. It's going to say if you push 9 and 6, it's going to turn on this B30. We go back to the main. B30 is going to be this guy here. Let me type it in real quick. So it's B3:0 /0. Okay, and you can't forget that part either, the /. I'll do the same thing here. I'm just going to drag them for speed things up. There's 1 and 2. There we go. So B30, B31, and B32. So when these are true, these come from the subroutine, and then with our additional switches we already have in there, it's going to do this. So let's go ahead and download it and see what it does. All right, I'm going to go online and put my PLC in run. All right, so my MCR is now, it's open. Let me change these all to maintained. Yep. So input 10 is going to be your MCR fence. So that fence is active. All right. We're not going to jump yet, but we're going to say that we are jumping over this. So if I was to turn on any of these right now, none of these would work because I'm jumping. I'm currently jumping over to this guy here. But I can turn on 5, and if I do this, it turns on this. But if you notice, B302, it lives in the subroutine, and we're not going to the subroutine yet. So I go to 10, I turn 10 on, all right, and then I go to the subroutine 3. All right, so in order to turn on 10, which one was that? Let me go back. All right, so I need to turn on 2, right? B32. So in order to turn on B32, I need to turn on input 18, which is right here. So if you do that, you should see that there it turns active, right? But let's go back to our original so we can watch it. All right, so now we're waiting on this guy here, and if I go to 8, this comes true, and that output just came true. So you see the output light up. So this lives in a subroutine, but now let's go and turn 10 off. All right, and this was left on. So if I turn off 8, 8's gone now, but now the bit is still active. You kind of see what I'm going there? Even though I have not jumping to the subroutine no more, I told it to stop going to the subroutine. It was in a true state when I left. And since I left, I went ahead and shut off 8. And if we go back to 8, don't forget, this 8 turns on that bit. But because it's not scanning it no more, it is stuck in this state. So it sees it off. So to fix that, we would have to go back to 10. As soon as we go back 10, click on 10, you're going to see B32 to shut off because it went back and scanned it and it said, oh, that's not there anymore. That input's gone. I'm now going to shut off the output. So you kind of see how that works. I hope you see how it works. Does that make sense? Is that where you kind of would leave a program and then do something and then come back to a program? Also, when you leave on rung, rung 1, you leave on 1, you're going to leave and go to the subroutine 3, and then you're going to come back on rung 2 and then finish your scanning. So you're going to get it all in the same thing. All right. Any of those? Anything? Do you need more explanation on that, or is everything good?
No, I'm good.
Okay, Brenda's good.
It adds up.
Okay, cool. All right, that's all I need to know. All right, let's move on to the next piece. If you guys need any more, we're on page 193, which is going to do immediate inputs and immediate outputs. And it'd be very hard for me to demonstrate this on screen because it's happened so fast. So, like I was saying earlier, we have 4 basic parts, and we'll take a break here in a second if you guys want to just stretch your legs. But basically, the 4 parts: read inputs. You're going to go to the next part. Is going to be your scan the program, update the outputs, and then do your housekeeping. Right. So you got the four pieces that make it logical. In between there, if you have something that happens very, very, very quickly, let's say like an encoder or a speed reference or something that is changing within milliseconds. It takes a millisecond or a couple milliseconds to scan a code, scan rungs. The longer the more rungs you have, the more subroutines you have, the longer it takes to scan. It slows the scan time down. But some things are so critical that you need to make double sure that it has not changed since you scanned it last. So these immediate inputs and immediate outputs, let's do the immediate input first. Let's say that it scanned it through its normal scan cycle and it said that something was off. Some kind of input was off, encoder, optical, something. Right? These things are happening within milliseconds changing, right? It goes to read the program, and the program, it reads through all the rungs, and on one of the rungs it says immediate input. And what that means is I want you to go back to this input and check it one last time before you go further. So it does, basically it stops scanning, it goes and checks that table one more time, just that one bit, and it says, has it changed? Yes, it has changed. I'm going to change my bit now. Or no, it hasn't changed. I'm going to maintain where I was off. Then it's going to continue on and then update outputs and so on. So it's telling it to go just for that one bit, wherever that instruction is, and say go back and check it one last time before we do any updates because something might have changed in the last couple of milliseconds. So again, it's very critical things that move very quickly. Unless it's something that's highly precision, I wouldn't even worry about that. I wouldn't even mess with them. The output is very similar. So the same thing happens, right? If I was to get ready to do my logic to do the output, before it does all its stuff, it's going to scan one more time and say, are you sure? Do I need to change and do I need to have this output come off and on or whatever, right? It's a complete instantaneous double check, basically. And that's what they're used for. There's another version of that called a immediate input with mask and immediate output with mask. A mask is basically what you would think a mask would do. It hides something, all right? So a mask is a word. So let's kind of explain what a mask is in general terms, right? So if you're gonna rob a bank or a follower, if you're gonna rob a bank and you needed to hide your identity, you would wear a mask, right? So let's say you wore a mask that just covered your eyes, so you had nothing else, you just had your mouth. The information that's getting through to the cameras is going to be your mouth section. The part that is being hidden is your eyes and what's going on there. So, um, part of the information is being received and part of it's being blocked. You kind of picture that with a face. Same thing happens here. There's a mask, which is basically it's a 16-digit word. It's 16 ones and zeros. If there's a one in place, it passes the information through, just like if we're not wearing any mask, right? It sees everything without being blocked. If there is a mask in place, then in that location, in that digit location, there's a one, and a zero. Sorry, if it's a zero, it's basically going to block it and say this information cannot pass. So whatever information was there last is what they're going to have. So let's say that I had 16 digits and my last two changed from a 1 to a 0, and I put a mask on there and I hide those, well, we got source, which is our original source. We have our mask, which is the middle, and then we have our destination. Kind of make a little sandwich, right? So imagine three bits. If it's coming in, it's the source, the mask, and the destination. The mask hides information from the destination. So if the source is your face, the mask is hiding it, and the destination is the camera that's picking up when you are robbing the bank. So you kind of see the parts and who does what. Now, for some reason, let's say that you want to block off a certain section, and put this in terms that maybe you understand a little better. Let's say you have a machine, a real long machine that has a bunch of safety doors on it, and if any of those doors were open, we would shut a machine down, right? The machine would die and we had nothing else. I need to work on this machine. I need access to those parts behind those doors. I need those doors open. I need the machine running so I can operate it. So I would put in a maintenance key. I'd stick a key and I would rotate it. It would set a mask in place, and the mask would say, okay, you are masking all the doors, so now you can walk over and open the doors, and the machine has no idea, because in the last state before the mask was in place, it saw the doors closed. Even though the switch is opened and it sees a 1 now, it doesn't know that. You completely masked it from its destination. So the machine is running as normal because you masked you masked it from the destination. The destination would have been the error, which would have shut the machine down if it had happened normally. To kind of explain a mask and what that mask is. So the immediate input, immediate output, and then both those versions have masks on them. Okay. Forcing. We're going to do forcing, and then I got a couple more. Then we'll take a break, and then we'll come back and do some quick labs. All right, forcing is a way to force something to be in a state which maybe the logic is not telling it to do. So let me kind of show you here on the screen. So let's say that this guy here, for some reason, let's pick on this guy here. All right, let's say that input 1-4. The switch that is associated with that, let's say it's damaged, and for some reason, I need to run this motor, but this pump the switch is damaged, and I can't get this pump to run. So what I can do, I can right click on it, I can go to force, and this one's slightly different, but I just want to kind of show you the things. So I go here, typically, and the other program goes a lot better. Let me just say that right now. Because you don't have to do this part of it. But let me show you what I'm doing here. So I want to force on. Well, first of all, I got to activate forces. That's right. The original program is much better at doing this than this guy is. Let me see if I can get it to play nice though. Force table. I want to force input 1. Let me see if it works. Okay. So I entered a 1. I told it to come on. And then up top here it says that forces do exist. Okay. So it's basically saying, are you sure? Because this is like, the context of a force, you are forcing something to happen that doesn't want to happen. you're telling it that a safety switch is being ignored, or whatever the logic is that says this thing is not should be running, you're telling it run. So it's asking you again. It's basically it's like a Windows saying, "Are you sure? Do you want to save this? Are you sure you want to delete this file?" It's that version of that. Okay. So basically, forces do exist, and then I have to go down here and say enable forces. And as soon as that happens, you're going to see right here it says forced on. And even though the logic says not to be on, I have now made this motor run. This thing here is now to the point where it's going to run forever. Like it's going to run till now until you turn the power off, right? That there's no condition in the world that's going to make the thing stop because you forced it on. But you can do the opposite. You can actually force it back off. So let me do the same thing. Click here, let me type a 0 in this spot, hit enter, and now I have forced it off, which means regardless of how the logic goes, and let me turn this line on so you see it. So I'll turn on 1.4, and then B31 is turned on by 1.7. All right, so let me go to 1.7 and turn on there. Okay. So now I have all three conditions are good, but this guy here is not turning on because he's being forced off. Now you see the symbols went away, but they're there, right? So he is not being allowed to do his thing. Let's see if I get that tail back for you. And when I went off it didn't like that, but in reality they would not do that. Okay. So again, I forced it off. So you can force things on. You can force things on where they never turn off. You can force things off where they never turn off, or you can remove a force. So there's three different options. So you force it on, you force it off, or you remove force. Remove force basically puts it back into auto. It lets it run normally. So for that, I would come in here. I would do the same thing. I would click on remove all forces, or I'd click and just hit delete. But I'll say remove all forces, and you see that it goes back to its normal state now.
So what is the difference between this forcing command and a latching circuit? I mean, you could do the same thing with the latching circuit by incorporating a relay.
But a latching circuit, it relies on the conditions to make that true.
You're still looking at an input instruction, right? To make that latch work, or even an internal relay. You could use an internal relay to make that work.
That's true. But let's say that one of the switches in that condition to make that happen, let's say one of those switches are damaged. Like it's a float switch that completely got ripped off, or it's a proximity switch or the head got completely sheared off. Like the switch is no longer there, but you need this thing to happen. In that condition, in that scenario you said, you would need that switch to be there, be present, in order for it to have that option to create that latch, you know? Aren't we still doing the same thing with the force? The force, it does have to have an input instruction for that. Nope. So with a force, you are basically just telling the output, you stay on. And regardless of what the conditions are, because you're missing, let's say that switch is missing, there's no way that wrong of logic is going to be completed. So, let's say like you're working night shift, third shift, there's no engineering department, you're on your own, you got to get this machine running, the parts department is closed, and you have no way to replace this switch, but you just sheared a switch, but you need to make sure this sump pump runs, or for whatever, right? You can force, well, there's a couple ways. You can rewrite the code to completely take that bit out, which, we all do. So you say, okay, you delete it, or you make it where it's not able to be turned off or whatever. There's another method I'll show you in a second, but you could do that and say, okay, I'm going to take it out of the code altogether so it doesn't rely on that, or you could force the output and say the output needs to stay on. Typically, when you force things, you're going to be around it. Like you're actually going to stay in that area and watch it, because if a sump pump, if the tank goes dry, you're going to burn your pump up, right? If it's a fan and something happens, so there's nothing going to shut that system off by itself. So you physically got to go in there and actually do your stuff. So a force just physically forces an output on and makes it makes it whatever it is, regardless of the instructions. Like the latch you said, the latch would take the conditions to set that latch, and then once the latch happened, it would go ahead and then allow it to latch, and then at that point it stays on until the unlatch, and then it drops out. So it's kind of it's just a different way of doing it. It's more of a troubleshooting purpose more than anything else. You would never just put a latch on and walk away from it. So another option is to, let's say that for some reason and this one doesn't have that option, but the other one does. Let me pull it up real quick and I'll show you the other one, because this is a good troubleshooting technique. I watched my whole computer crash because I'm running two of them, but it's all right. It's all good. All right, so let's go here. We'll take a break here in a second. I promise. We're just want to get this out of the way, and then we'll move on to our next thing. Okay, so this option, this is the one that I'm having you guys download. This has more options. So typically, you would right click, you would go down to force, you would force it on. It would say, "Are you sure?" I'm not running. It would say, "Are you sure?" And then it would say that you do the same thing, enable forces, and then from there you would do whatever. I have no addresses, so it's not even gonna let me do it. But another option is to toggle a bit. A toggle is basically a digital version of pushing a button. So if you were to walk over to a physical push button and push it and release it, that's a toggle. It toggles it. It turns it off and on. For some reason, let's say that you needed to activate a switch that is very, very far away. You can physically see it. You're safely in that zone, but it's very far away. So what you would do is you would toggle that switch to act like something actually triggered it. And I'll give you a good example. We did this quite a bit when I was working at the park. Some of the switches that were maybe at the top of the coaster, we could see the whole coaster, right? We can see, make sure we're safe and everybody's good. If you don't want to climb to the very top to test that switch to make sure the logic is working, you could toggle that bit, and it would act as if a train had gone over that spot, and then we could test our safety systems or whatever we had to test, right? We didn't want to physically have to climb through every single time because there's 50 switches on a lift. You don't want to check every single one and go up and then go back to the computer room and then go back up and So you put on 10 miles of walking back and forth, but doing that. So you sit in the control room, you have someone outside a radio, and you toggle each one, and you make sure that all the systems are working. So that's a way you're actually physically monitoring a system by simply toggling a switch off and on. So you can make a false that someone pushed a button, or you can have it where whatever. But toggles only work momentarily. That's almost like someone pushing a button and stopping. Whereas a force is forcing. You can force an input. It's not advised, but you could force a input on or off. That's also an option. If you wanted to say, okay, this switch is completely gone, I need to force it. And you can also, there's something called this is not advised either, but you can create something called a never false information, which is called a NFI. And basically what that means is you create a bogus. So let me just make a a lot of weird things going on there. So B3 colon I'll say 10, and then I'll say /0. I don't know. I'm just kind of some random bit that is not being used by anything. And I'm going to make it, let me change the symbol. So this should be there you go. Change instruction type. I want to change it to examine if open. So NIO. Oh, lost it. B3. Like I said, it's just a bogus address. Nobody's using it. It's on its own. And this one here is an output. So let's say this is a All right, so if I was to go online with this rung would never go false, right? So if I need to turn something on, this is a trick that, again, if you use this a lot, you can get yourself in trouble, because if you lose track of these and who they are and where they are, so sometimes it's good to always go in there and say that you give it an actual name, and you call it a right. So it's never false. It never turns off. It's always on. So that's an option. You can also have one that's never true, and same thing. You could just have one that is the exact opposite, that is simply just never ever comes on. That is a way to troubleshoot as well, but that is not the proper way. So what you could do here, I could sit there and I could toggle this thing, and so when I toggled it, I turned it off. Even though it's an NFI, it's never false. I forced it and said, I need to toggle you to turn you to the off. So now this rung is false, but I can go back and toggle again and turn it back on. So it's simply like me pushing a button, if that makes sense. Or I can go over here to the output and say, I need you to force on. All right, forces are enabled, forces are installed, and it's on. And this guy he's currently running. So if we went to the, well, I just crashed my thing again. If I go to the, I did you see that? Turkey. Okay, anyways, it would show that this is on. It's definitely my simulator. I think that's my issue. Okay, so you get the idea. Forcing is a way to force things either on or off. If you want to disable it or take the forces off, you remove the force. So if it's on, don't force it off, right? Because it'll never come on. Just say remove force, so it takes it away. Toggle changes the position, changes what it's doing. And then you can do things like NFIs and that kind of stuff. But it's, again, those are things you don't want to do unless you really know what you're doing, because if you lose track of those, you can get yourself in some big trouble. Okay, that takes care of forcing. Real quick, safety circuits. We talked about with safety circuits, we have things that are like, oops, went away. Come back. There we go. Master control relays, which is a physical relay. We talked about this at the very beginning. A master control relay is a physical relay that is in from the power source to your motor or whatever you're doing, and it physically breaks the circuit. This would be like a emergency or whatever, emergency stop. There's things called ESRs, emergency stop relays. You can have those embedded as well. So emergency stop would stop all movement, where a master control relay might cut off all power, or however you want to organize that. But those are physical contacts, electromechanical contacts that are in place of if something happens, if something faults or some reason something goes wrong, it kicks that off and physically removes power from the circuit, or even at best it pulls power away from the output card, not the PLC. You don't want to make this thing have no brain, no thought process, right? You just want to cut off all output, so it has no ability to turn anything on. There's a great picture of that on page 198 also. All right, there's 4 more, and then that's it, and then we will take our break. So first one is called selectable timed interrupt. This is a way at a time base, not an event base. Now, an event base could be MCR is an event base, right? Something happens, it sets a bit, it sets an MCR, and then all of a sudden something happens. That's an event. This is time based. We actually have a time, and this, after a certain period of time, it will trigger or go to a fault routine. And I'll talk about fault routines in a second. But you can actually set up a subroutine that is nothing but, let's say okay, something was to happen, and you would make this line true, whatever, and then after a certain period of time, right, it would automatically defer. It would stop the main scan. It would scan to a subroutine, and then it would start reading that subroutine. And you designate that as your shutdown or whatever it is, which brings us to the next one. It's called a fault routine. That's number 2. Fault routine is basically a routine that brings everything to a safe state. So if you were to stop a machine's running, it's processing, parts going through it, everything's working, all of a sudden you stop it, you're going to do some damage to the machine, you're going to damage product, you're going to damage a lot of things. Especially your advanced manufacturing does not just stop. right? Things are flowing, and there's a lot of inertia, a lot of things going on. So a fault routine, if it's not an emergency, like an e-stop relay, that would shut off everything. That would stop it because somebody's possibly getting hurt. This one here is more like um, the processor itself is faulted, right? Instead of just going and fault and everything's done, it's going to go to this fault routine, and the fault routine says, all right, we're in a fault condition. I need you to spool down the motors. I need you to start setting the brakes. I need you to go dumping the air pressure. I need you to what? It starts going through routine to get everything to a safe state, and then it stops. It's not something that just runs and runs and runs. It basically gets it to a safe state. So that's what that means. Temporary end. This is on page 201. Temporary end is basically an instruction that, remember I showed you earlier at the very last rung it says end. You can put a temporary end anywhere in your logic, and what's going to happen is going to be you can customize, or you could troubleshoot a section of logic at a time. So let's say you read the top 10 lines, 10 rungs. All of a sudden you put a temporary end. Let's say I have an unconditional. It's going to read that and go back home. All right, go back to the main, or whatever it is. It's the end of that system. You're actually, or if you put it in 2, you can put it in rung 2 or in program 2. It will get to that point, and then it'll sit there and stop. So when I mean stop and then go to the top and repeat over and over and over to that point. If you put a condition on it, you can make a conditional where only in this condition do you stop here and go back. You don't. But that means anything beyond that is not getting scanned. That means, so if it has anything that has what's going on beyond that, it's a temporary end, which means it's going to end temporarily at this point here and go back home. Home being the rung 0, versus trying to scan the rest of the program. So it's a way to troubleshoot more than anything. And then you have a suspend instruction, which basically, when a fault is detected, it stops the program right where it's at, and it logs exactly the scan, the rung, the bit that faulted, and allows you to locate and say, okay, there's our problem, or here's our issue, or it kind of pinpoints things faster. So you have a very, very large program, thousands of lines of code. It's easier to have to suspend it and stop it. You're not running when you use these things here. Typically, you're just doing testing. You're doing commissioning for something. You're not actually physically running a machine, because it literally just stops. But it allows you to find problems in the code, and it's called a suspend instruction. So